Doug Coughlin. Welcome to my garage. I've retrofitted a couple of these DynaMyte 2400 CNC mills using the modern BuildBotics CNC controller. In this how-to video, I'll show you how it's done. Specifically, I'll make some suggestions for how to mount the controller, and I'll show you how to wire up the power supply, wire up the motors, and the limit switches. I'll show you how to connect the spindle, and I'll show you how to connect an auxiliary AC outlet. Finally, I'll show you how to configure the controller for the Dyna 2400. With that, let's get started.
CNC machining and working on electronic circuits can be hazardous. Hazards can arise from many sources, including, but not limited to, personal error, machine or controller malfunctions, exposure to electricity, exposure to chemicals, flying material, rotating machinery, pinch points, hot surfaces, defective hardware or software, or improper instructions. Neither Doug Coughlin nor BuildBotics LLC make any claims that the instructions or advice given in this video are fully accurate or complete. Neither BuildBotics LLC nor Doug Coughlin are responsible for any injury, equipment damage, lost time, or financial losses that result from the use of this video or its content. Your use of this video and or its contents mean that you will not hold Doug Coughlin or BuildBotics LLC responsible for any injury, equipment damage, or financial losses that may result from information provided in the video or from the use of the BuildBotics controller. For your safety, make sure the power is turned off and the Dyna is unplugged before disassembling any part of the machine and whenever electrical wires or circuits are exposed. I recommend deciding where you want to locate the BuildBotics CNC controller before starting to make electrical connections, because the location of the new controller will determine how long the cable should be. It's not absolutely necessary to mount the controller in plain view, but I do find it helpful to be able to see the LCD display while running the Dyna. Here are a couple of examples. In one case, I mounted the controller to the side of the machine using a couple of shelf brackets that I bought at the local hardware store. In another case, I modified the plate that was used to hold the original touch panel controller and mounted the BuildBotics controller on that plate. Another alternative would be to not mount the controller at all and simply sit it on a table next to the machine. Make sure the Dyna is unplugged and turned off before removing the cover from the back cabinet to prevent exposure to hazardous electricity. Disconnect all cables from the old motor control board. Otherwise, you'll get an obnoxious alarm when you turn on the machine. Optionally, you can completely remove the motor control board. The motor control board is mounted on the left wall when facing the back of the Dyna. Connect the BuildBotics controller to the existing 24-volt power supply using the pre-made power cable supplied by BuildBotics. Connect the three red wires to the plus terminal on the 24-volt power supply inside the cabinet on the Dyna, and connect the three black wires to the minus or ground terminals on the 24-volt power supply. Plug the other end of the pre-made cable into the 12 to 36 VDC power jack on the back of the BuildBotics controller. The motor on each axis must be connected to the respective port on the back of the BuildBotics controller. You need to decide whether to run the cables outside the machine or attempt to reuse the internal wiring for the old motors. I have successfully used the internal wiring for the motors, but not the limit switches. You may find the internal wiring is no longer usable for either the motors or the limit switches, in which case all cables will be run outside. First, remove the housing and motor cover to access the motor driver. Next, remove the motor driver, leaving the motor connectors behind. Beware of chemical hazards that may be present on the old motor drivers. I recommend wearing protective gloves and a respirator while removing the old drivers. Also, be sure to properly dispose of the old motor drivers using the procedures established for e-waste disposal in your area. 3 connectors are exposed after the motor housing and motor driver are removed. The 8-pin connector comes from the motor. The 6-pin connector attaches to internal wiring that connects through the machine to the control cabinet. The 2-pin connector attaches to internal wiring that goes to the limit switches. The motor wiring is the same for each axis, but the limit switch wiring is slightly different for each axis. The color coding on the motor wiring is likely to be faded, so it's important to keep track of the wires. I did this by cutting the wires off and attaching them one by one. There's a 1 on the 8-pin motor connector designating pin 1. This schematic shows the connections from the motor jack to the 8-pin connector coming out of the motor. Pin 5, A- is connected to pin 6, A'+, and pin 7, B- is connected to pin 8, B'+, on the 8-pin connector. This configures the motor as bipolar series. Note that A+, pin 1, A'- pin 2, B+, pin 3, and B'- pin 4 on the 8-pin connector are connected to A+, A-, B+, and B- respectively on the build-body's controller jack. This diagram also shows how the internal wiring is connected. The internal blue wire extends B- through the machine from the controller to the motor. The green wire extends A-, the red wire extends A+, the orange wire extends B+. Not all of the internal wires are used. It's tempting to try to use the extra wires for limit switches, but I found that there is too much noise coming from the motor wires to operate the limit switches reliably using the internal wires, so the limit switches are routed outside the machine. The limit switch wires extend from the 2-pin connectors inside the motor housing to the build-body's controller via the DB25 breakout box that plugs into the back of the controller. The DB25 breakout box comes with the controller. Since the wiring is run outside the Dyna housing, it's important to make sure that the wires have enough slack to accommodate machine movements. Additionally, the wires should be flexible and be able to withstand oil and coolant chemicals used with the machine. I use 18-gauge type MTW stranded wire. Limit switch wires are accessible inside the motor housing on the 2-pin connector. The connections for each axis are slightly different. Connect the yellow wire on the 2-pin connector at the Z motor to pin 10, max Z, on the DB25 connector. Connect the black wire on the 2-pin connector at the Z motor to pin 7, ground, on the DB25 connector. Connect the green wire on the 2-pin connector at the Y motor to pin 5, min Z, and connect the black wire on the 2-pin connector at the Y motor to pin 7, ground. Connect the orange wire on the 2-pin connector at the X motor to pin 3, min X. No ground wire is connected for the X axis because the ground wire is connected to the ground for the Y axis inside the machine. Finally, plug the DB25 connector into the controller. These connections will provide the ability to turn the spindle on and off from the build-body's controller. The speed continues to be controlled with the rheostat on the side of the spindle. Start by cutting off the 3-pin connector that has a black wire and a blue wire only and attaches to the motor control board on the side of the Dyna cabinet. The black wire remains connected to the bottom pin on the 9-pin connector attached to the spindle control board. The blue wire remains connected to the bottom terminal on the back of the program local switch. You may want to verify that you have the correct wires with an ohm meter. 3 connections are required. Connect the ground, pin 19 on the DB25 connector, to the ground minus terminal on the 5-volt power supply in the Dyna cabinet. Connect from 3.3 volts, pin 20 on the DB25 connector, to the blue wire from the 3-pin connector. Connect from spin able, pin 15 on the DB25 connector, to the black wire from the 3-pin connector. In order for the BuildBotics controller to control the spindle, the program local switch on the front of the cabinet must be in the program position, and the spindle off-on switch on the side of the spindle must be on. The user of the Dyna wants to use a coolant pump in conjunction with the Dyna. This diagram shows the circuitry required for controlling the auxiliary receptacle on the Dyna from the BuildBotics controller. First, a GR2-1A-DC24 24-volt relay was mounted to the mounting panel inside the Dyna control cabinet and near the back of the auxiliary receptacle. The black primary hot wire feeding the auxiliary receptacle was cut, and the relay contacts were connected to the cut ends of the wire. BuildBotics supplies 2 pre-made load cable stubs for connecting to the load jacks on the controller. Using one of those stubs, the 3 black wires from the stub were spliced together and spliced to a single black wire. That black wire was connected to one side of the relay coil. Similarly, the 3 red wires from the stub were spliced together and to a single red wire. The red wire was connected to the other side of the relay coil. Finally, the load cable stub was plugged into the back of the BuildBotics controller. The wiring is now complete. Now we need to configure everything. Put the cover back on the machine and plug it in. Attach the BuildBotics controller to the local area network, turn on the Dyna, and enable the BuildBotics controller. Connect to the BuildBotics controller using a web browser. We'll start by configuring the X-axis motors and limit switches. Select motor 0 and set the configuration as described. Axis will be set to X. Power mode is when moving, drive current is 1.8 amps, idle current is 0. Reverse is checked. Microsteps is 32 microsteps per full step. Max velocity is 0.762 meters per minute. Max acceleration is 100 meters per minute cubed. Max jerk is 50 kilometers per minute cubed. Step angle is 3.6 degrees. Travel per revolution is 0.25 millimeters. Min soft limit is set to 0. Max soft limit is set to 150 millimeters. Min switch is normally open, max switch is disabled. Homing mode is set to switch min, meaning it will look for the minimum switch. Search velocity is 500 millimeters per minute, latch velocity is 100 millimeters per minute, latch back off is 5 millimeters, and 0 back off is 5 millimeters. Save your work and move on to motor 1. We're setting motor 1 to axis Y. Power mode, drive current, and idle current are all the same. Reverse is not checked on the Y-axis. Microsteps, max velocity, max acceleration, max jerk, step angle, and travel angle are all the same as they were for the X-axis. Min soft limit is the same. Max soft limit is 120 rather than 150. Min switch is normally open, max switch is disabled. Homing mode, search velocity, and latch back off, and 0 back off are all the same as they were for X. So save your work again and move on to motor 2. We're setting motor 2 to the Z-axis. Power mode is when moving, drive current, idle current are the same. Reverse is checked as it was on the X-axis. Microsteps is 32, max velocity, max acceleration, max jerk, step angle, and travel per revolution are all the same. Min soft limit is set to -60, max soft limit is set to 50. The min switch is disabled, and the max switch is set to normally open. This is because the switch is actually at the top of the axis on the Z-axis. Homing mode, search velocity. Homing mode is actually set to switch max rather than switch min. Search velocity, latch back off, and zero back off are all the same. So save your work, and now the motors and limit switches are configured. Next, we'll configure the spindle and the load switch that serves the auxiliary receptacle. Select the Tool field and set the following fields. Spindle type will be set to PWM, and Tool Enable Mode will be set to High-Low. None of the remaining fields matter because we're not controlling speed. Save your work and select I/O. Now set the e-stop to disabled. The Dyna has a hardware e-stop built in that's not controlled by the BuildBotix controller. Probe is disabled. Load 1 is set to low-high, meaning when the switch is high, the receptacle will turn on. Load 2 is disabled, and fault is disabled. Congratulations! The Dyna is ready to go with the new BuildBotix controller. Thank you so much for watching this video. For more information, including a link to the full text with images for this video, join the BuildBotix forum at forum.buildbotix.com. To learn more about the BuildBotix CNC controller, go to www.buildbotix.com. To purchase a BuildBotix CNC controller, go to store.buildbotix.com.